Hi 10th, welcome back to my channel. So today we are going to wind up exercise 8.1. Last few days we were discussing about exercise 8.1, and only one more question is remaining in that exercise. So as I mentioned, through today's video session we are going to wind up exercise 8.1, and next day onwards we will go to the next session. Okay, few more sessions are remaining in this chapter. I expect this month itself we could complete this chapter effectively. So without wasting much time, let me discuss the remaining question. See, നമ്മൾ ഓരോന്ന് പഠിച്ചിട്ട് പോകുന്നതും വളരെ ഇൻ ഡീറ്റെയിൽഡ് ആയിട്ടാണ് പഠിച്ചിട്ട് പോകുന്നത്. എല്ലാ കോർണറും ടച്ച് ചെയ്ത് നിങ്ങൾക്ക് OMR എക്സാമിന് ഏത് റീജിയനിൽ ചോദിച്ചു കഴിഞ്ഞാലും ഒരു ഡൗട്ടും ഇല്ലാണ്ട് ആൻസർ ചെയ്യാൻ പറ്റുന്ന രീതിയിലാണ് പഠിപ്പിച്ചു പോകുന്നത്. അതുകൊണ്ടാണ് കുറച്ച് സമയം എടുക്കുന്നത്. നമുക്ക് ഈ മാസം കൊണ്ട് തീർക്കാമെന്ന് തന്നെ വിചാരിക്കുന്നു. ഇനി ഏറിപ്പോയ അടുത്ത മാസം ചിലപ്പോൾ ഫസ്റ്റ് വീക്കും കൂടെ ഉപയോഗിക്കേണ്ടി വരുമായിരിക്കും. എനിക്ക് അറിഞ്ഞുകൂടാ. ഞാൻ മാക്സിമം ഈ മാസം തന്നെ തീർക്കും. കാരണം ഓടിച്ച് തീർത്ത് കഴിഞ്ഞാൽ എനിക്ക് തീർക്കാൻ പറ്റും. എനിക്ക് തീർക്കാൻ ഇപ്പോൾ എന്താ പറയുക, ആദ്യത്തെ എക്സസൈസിൽ 2-3 ക്വസ്റ്റ്യൻ ഡിസ്കസ് ചെയ്ത് ബാക്കിയുള്ളത് ഹോംവർക്ക് ചെയ്തിട്ട് തന്നിട്ടും തീർക്കാം. പക്ഷെ അങ്ങനെ ഞാൻ ചെയ്യില്ല. ഞാൻ നിങ്ങളോട് പല പ്രാവശ്യം സൂചിപ്പിച്ചാണ്. കാരണം അങ്ങനെ ചെയ്തിട്ട് നമുക്ക് കാര്യമില്ല എന്നുള്ളതാണ്. നമുക്ക് എല്ലാ ഏരിയയും ടച്ച് ചെയ്ത് പോകണം, പഠിക്കണം. നമ്മൾ ചെറിയ കാര്യമാണ്, ഒരു ചെറിയൊരു പോർഷനാണ് പഠിക്കുന്നതെങ്കിലും അത് ഡീറ്റെയിൽ ആയിട്ട് പഠിക്കണം. അതാണ് എൻ്റെ പോളിസി. അപ്പം നമുക്ക് നന്നായി നിങ്ങൾ ആഴത്തിൽ പഠിക്കണം. ഓക്കെ, അതിന് വേണ്ടിയിട്ടാണ് ഇത്ര സമയം എടുക്കുന്നത്. സോ ഇനി നമ്മൾ ക്വസ്റ്റ്യൻ നമ്പർ നമുക്ക് ഇതിൽ ഇനി ഉള്ളത് ക്വസ്റ്റ്യൻ നമ്പർ 11 ആണ്. നിങ്ങൾക്കറിയാം ക്വസ്റ്റ്യൻ നമ്പർ 10 നമ്മൾ കഴിഞ്ഞ ദിവസം ഡിസ്കസ് ചെയ്തു. So we are going to discuss about question number 11. See, you are supposed to just state whether these statements are true or false. So you may think that stating true or false, this is a kind of very simple question and less important because it is for marking true or false. So see, this is a true or false type of question, but this is very important. You can expect this kind of question in OMR exam. Clear? Do not consider as less important, very important. Okay, so first, which is the first statement? Okay, which is the first statement? The value of tan A is always less than 1. The value of tan A is always less than 1. That is the first statement. I'm going to check, or we are going to check whether this statement is true always. The value of tan A is always less than 1. That is a statement given. So let me check whether this statement is true always. Okay. There may exist some situations where tan A is always less than 1. But there may exist some other situation where tan A is greater than 1. We are supposed to check that. Okay. So in order to check that statement is true always or not, I'm going to consider an example. See, let me take an example. Okay, that statement says that tan of an angle A, that is tan A, is always less than 1. So that statement says that tan A is always less than 1. The value of tan A is always less than 1. Let me check by using an example whether that statement is correct or not. Okay, I told you this kind true or false kind of question is very important. So in order to check that, let me consider a right triangle, and where angle B is equal to 90 degree, and I am marking the side as 3, 4, 5. So my first question is, can I draw a right triangle with 3 sides, 3, 4, 5? Yes. Why? Because while you are marking sides for right triangle, you should be alert. That side should be always Pythagorean triplets. Simply we cannot draw a right triangle. We cannot give some sides. No, never. When we give sides for the right triangle, you should be alert. We cannot give 3 numbers as a side. No. That side should be Pythagorean triplets. That means, what do you mean by Pythagorean triplets? That side should satisfy Pythagoras theorem. Let me check these 3 sides are satisfying Pythagoras theorem. If these 3 sides are satisfying Pythagoras theorem, then we can use that sides as sides of a right triangle. Otherwise, we cannot. So let me check whether these 3 sides satisfy Pythagorean Pythagoras theorem. Okay, if these 3 sides are satisfying Pythagoras theorem, this is known as Pythagorean triplets. If it satisfies Pythagoras theorem, okay, So for a right triangle, in order to give some measurement for three sides, that three sides should be Pythagorean triplets, or that three sides should satisfy Pythagoras theorem. So let me check Pythagoras theorem. Pythagoras theorem says that hypotenuse square is equal to base square plus height square. No, Pythagoras theorem, the statement is hypotenuse square is equal to base square plus height square. Okay, and see, this is actually not needed for this purpose. Which purpose? We are supposed to prove that tan is always less than 1 or not. Okay, ഇത് ഞാൻ എഴുതുന്നത് ഞാൻ വെറുതെ ഇങ്ങനെ ഒരു 3, 4, 5 എവിടെയെങ്കിലും വായു എന്ന് എടുത്തിട്ട് വെറുതെ മാർക്ക് ചെയ്തതല്ല. 3, 4, 5 ഒരു റൈറ്റ് ട്രയാങ്കിളിൻ്റെ സൈഡ്സ് തന്നെയാണ് എന്ന് ബോധ്യപ്പെടുത്താൻ വേണ്ടിയിട്ടാണ് കേട്ടോ. ഹൈപ്പോട്ടനസ് സ്ക്വയർ ഇസ് ഈക്വൽ ടു ബേസ് സ്ക്വയർ പ്ലസ് ഹൈറ്റ് സ്ക്വയർ. സോ ലെറ്റ് മീ ചെക്ക് ദീസ് ത്രീ സൈഡ്സ് സാറ്റിസ്ഫൈ ദിസ് റിലേഷൻ. Okay, so what is here hypotenuse square? 5 square, so it becomes 25, isn't it? Hypotenuse square is 5 square, that is 25. Okay, so I calculated hypotenuse square. That means LHS side I calculated first. Then I am going to take RHS side. What is that? Base square plus height square. Okay, I am going to check whether these three sides satisfying this result or not. Okay, that's why I am doing step by step. And base square plus height square. What is base square? 3 square. Height square 4 square. So it becomes 3 square plus 4 square. That is 9 plus 16. That is 25. Now we just see. Base square plus height square, the value is 25. Hypotenuse square value is 25. Both are same, no? That means hypotenuse square is equal to base square plus height square. That means these three sides satisfy Pythagoras theorem. Clear? So we can easily give the sides of a right triangle as 3 cm, 4 cm, 5 cm, because they are Pythagorean triplets, or these three sides satisfy Pythagoras theorem. Okay, now I am going to calculate tan A. So what we did, we draw a right triangle and we give three sides for that right triangle, and we understood that these three sides are Pythagorean triplets, so we can easily give 3, 4, 5 as the sides of a right triangle. Now I am going to calculate tan A. Why? Because here the first statement, we are supposed to check the validity of the statement tan A is always less than 1 or not. That's why I calculated tan A. So tan A, what is the value of tan A in this triangle? Tan A is equal to opposite by hypotenuse, 4 by 3. Can you tell me the value of 4 by, see, is it correct? Yes, tan A is equal to 4 by 3. In this right triangle, tan A is equal to 4 by 3. What is the value of tan A, this 4 by 3? This is greater than 1 or less than 1. I told you once, if the numerator is greater than the denominator, then the value of that fraction should be always greater than 1. If the denominator is greater than the numerator, then the value of the fraction should be less than 1. I repeat, if the numerator is greater than the denominator, then the value of fraction is greater than 1. Here the numerator is greater than the denominator, so value of this fraction is always greater than 1. Otherwise, you just calculate the value of 4 by 3. You will get a quantity greater than 1. Sure, calculate if you want. Okay, that means this example says that tan A is greater than 1. This example is a right example because these three sides satisfy Pythagoras theorem. So we can easily give these three sides as the sides of a right triangle. So when I calculate tan A by using this example, tan A is greater than 1. So can you say that the given statement is correct always? No. Given statement is tan A is always less than 1. But we found an example where tan A is greater than 1. So the first statement is false. Tan A can be less than 1 in some cases, but we cannot say tan A is always less than 1. Okay, because we found an example where tan A is greater than 1. So first statement is false. Okay, so what you can write, see here in this way you can write, first you just write the statement, the value of tan A is always less than 1, then semicolon, then you can write this statement is false. Okay, because this is a reason. In that way. Then second statement, write that CK is equal to 12 by 5 for some value of angle A. This is the question. This is the statement. The second statement, they said that CK is equal to 12 by 5 for some value of angle A. No need to focus here. You just focus here. It is given as CK is equal to 12 by 5. The question says that the value of Ck is equal to 12 by 5. We are supposed to check whether the value of Ck can be 12 by 5 or not. That is our task. Clear? The statement given that Ck is equal to 12 by 5. We are going to check whether this Ck can be 12 by 5 or not. Are you following me? Yes. See, I am going to check whether this Ck can be 12 by 5 or not. See, Ck is equal to 12 by 5. What is the value of 12 by 5? Numerator is greater than the denominator. Now here the numerator is greater than the denominator. That means this 12 by 5 is always greater than 1. So this statement Ck is equal to 12 by 5, it says that Ck is greater than 1. Are you following me? Once again, let me repeat. See, here the statement is given that Ck is equal to 12 by 5. We are supposed to check the statement of validity of the statement. That means we are supposed to check whether Ck is equal to 12 by 5 or not. Okay, so what is the value of 12 by 5? 12 by 5, we know that 12, here the numerator is greater than the denominator. So 12 by 5 is a value greater than 1. So Ck is equal to 12 by 5. It says that Ck is greater than 1. കാരണം എന്താ 12 by 5 എന്ന് വെച്ചാൽ 1-നേക്കാൾ വലിയൊരു ക്വാണ്ടിറ്റിയാണ്. അപ്പോൾ Ck 12 by 5 എന്ന് പറയുമ്പം Ckൻ്റെ വാല്യൂ 1-നേക്കാൾ വലുതാണെന്നല്ലേ ഇതിൻ്റെ അർത്ഥം. കാരണം എന്താ, here the Ck is given as 12 by 5. We know that 12 by 5 is a value greater than 1. So we can easily write that Ck is greater than 1. Okay, so instead of checking the validity of this statement, now it is better to check the validity of this statement. Why? Because Ck is equal to 12 by 5. It also implies that Ck is greater than 1. Are you following me? So instead of checking the validity of this statement, now I am going to check the validity of this statement because both are same statement. Okay, now I am not going to repeat once again. You may understand it. So let me check the validity of this statement now. Okay, because to check the validity of this statement, this is a little bit difficult to check. Okay, so I'm going to check the validity of this one. This one easily can be done. Clear? That means the value of Ck is greater than 1 or not. Let me check it. Clear? In order to check the validity of this statement, I'm going to consider the same example. Okay, what is the need of drawing another example? Same example we can consider, no? See, I'm going to calculate the value of Ck. What I'm going to do, I need to check whether Ck is greater than 1 or not. So let me calculate the value of Ck. Then we will check then Ck. What is the value of Ck? Ck, the definition, tell me. Hypotenuse by adjacent, because it is inverse of cos A. Hypotenuse by adjacent. What is hypotenuse? Ck. This is the angle A. So hypotenuse is 5 and adjacent is 3. So answer is 5 by 3. So we got the value of Ck as 5 by 3. It says that Ck is greater than 1. Why? Because, who can say? Because we got the value of Ck is 5 by 3. And here the numerator is greater than the denominator. So that means this 5 by 3 is a value greater than 1. That means Ck is greater than 1. Once again, we understood that from this example Ck is equal to 5 by 3. 5 by 3 is a quantity greater than 1 because numerator is greater than the denominator. So Ck is equal to 5 by 3 means 5 by 3 is a quantity greater than 1. So when we connect all those things, we can easily conclude that Ck is a quantity greater than 1. That means Ck is greater than 1. എന്താ നിങ്ങൾക്ക് മനസ്സിലായോ? ഒന്നുകൂടെ പറയുന്നു. Ck 5 by 3 കിട്ടിയത്. 5 by 3 എന്ന് വെച്ചാൽ ഒന്നിനേക്കാൾ വലിയൊരു സാധനമാണ്. അപ്പോൾ Ck എന്ന് പറഞ്ഞാൽ ഒന്നിനേക്കാൾ വലിയൊരു സാധനം എന്നല്ലേ ഇതിൻ്റെ അർത്ഥം. See, so this statement is correct. So this statement is true. This is the reason. Here you can write true. This is the reason. See, when we use this example, we got Ck is greater than 1. So this statement holds. You may understood, no? So moving to the third statement. Okay. See, I forgot to teach you that third statement. That is not so important. That's why I left that one. See, that is not a topic, but still you have to understand the fact that sine, here you can write as a note. Sine, this sine is the abbreviation or short form. Okay, sine is the abbreviation or short form of SINE. Actually, it was sine. but in short we will use sine. Clear? Then cos is the, we discussed about cos, no? Actually cos came from the word, or cos is the abbreviation of, or cos is the short form of cosine. What? Cosine. Clear? Then it is for just, you just read this, that is enough. No need to buy heart this kind of, all those things are not, because this is not important. But still you can expect this kind of a question in OMR question paper. So for that purpose, just learn it. Okay, sine is the abbreviation of sine, cos is the abbreviation of cosine. Then tan is the short form, or tan is the abbreviation of tangent. Actually it was tangent. For the daily use we made a shortcut of tangent and we call it as tan. Actually tan came from tangent. Okay, then cosec. Cosec came from, or cosec is the short form of cosecant. Cosecant. Okay, cosecant. Then sec is the short form of secant. Secant. Cot is the short form of cota. I forgot, let me check. Cot is the short form of cotangent. Cotangent. Okay, just read it, that's enough. And the third statement says that, write this, now you can write the third statement. Third statement says that cos A is the abbreviation of cosecant. Is it correct? No, cos is the abbreviation of cosine actually. We discussed just now. Cos is the abbreviation of cosine. But the third statement says that cos is the abbreviation of cosecant. No, cos is the abbreviation of cosine. So you can write that that statement is wrong, because cos is the abbreviation of cosine. Actually, what is the abbreviation of cosecant? Cosecant, its abbreviation is actually cosec. But they said that cosecant is the, oh sorry, തിരിഞ്ഞു. എന്താണ് ഞാൻ പറഞ്ഞത്? Actually cosec is the abbreviation of cosecant. But they said that in the statement cos is the abbreviation of cosecant. No, cos is the abbreviation of cosine. Clear? So third statement is wrong. You can write the reason. Cos is the abbreviation, or cos is the short form of cosine, not cosecant. Clear? Okay, moving to the fourth statement. We are going to check the validity of the fourth statement now. See, now fourth statement, it says that cot A is the product of cot and A. No, it's a wrong statement, because cot A stands for, they says that cot A is the product of cot and A. So they said that cot A is nothing but cot into A. No, product means into. So this statement says that cot A is the product of cot and A. That means this statement says that cot A is nothing but cot into A. No. Cot A means we are applying the ratio cot on angle A. Okay, it is not the product of cot and A. While we write, see, okay, very simple thing. While we write cot A, what is the exact meaning of that sentence? We are applying the ratio cot on angle A. That is the exact meaning. Okay, but this statement says that cot A is cot into A. No, never. So that statement is wrong. Okay, so you can write cot A is the product of cot and A, then semicolon. This statement is wrong, because cot A is defined as what? Cot A is defined as cot A defined as, no, we can write like this. Cot A stands for apply trigonometry ratio cot on angle A. Clear? Okay, so that's it. Now the very last sentence, what is that? Very last statement. Sin theta is equal to 4/3 for some angle theta. That we are going to check. What? Sin theta is equal to 4/3 for some angle theta. Okay, that means we are supposed to check the fifth statement's validity. That means they said that sin theta is equal to 4/3. So we are supposed to check, can sin theta is equal to 4/3? If sin theta can be 4/3, then that statement is correct. If sin theta cannot be 4 by 3, then that statement is wrong. Clear? So what we are supposed to check? We are supposed to check, can sin theta is equal to 4 by 3. Okay. So they said that, you just write the statement as it is. Sin theta is equal to 4 by 3 for some angle theta. Clear? Then we are going to check its validity, whether that statement is wrong, correct or not. See, they said that sin theta is equal to 4 by 3. What is the meaning? What is the speciality of the quantity 4 by 3? Here the numerator is greater than the denominator. That means 4 by 3 is a value greater than 1. Are you following me? You may understood, no? Last few problems we applied the same concept. So they given that sin theta is equal to 4 by 3. We know that 4 by 3 is a quantity greater than 1. So it says that what? Sin theta is greater than 1. How many of you understood? Repeating once again. It says that sin theta is equal to 4 by 3. Here the numerator is greater than the denominator. That means 4 by 3 is a quantity greater than 1. If 4 by 3 is a quantity greater than 1, so they said that sin theta is greater than 1. കാരണം എന്താ sin theta 4 by 3 എന്ന് അവർ പറഞ്ഞേക്കുന്നത്. ആ 4 by 3 greater than 1 ആണെന്ന് നമുക്കറിയാം. അപ്പോൾ sin theta greater than 1 ആണെന്നല്ലേ ഇതിൻ്റെ അർത്ഥം. So this statement says that sin theta greater than 1. But you can write like this in the note. But can sin theta greater than 1? Let me check an example. Same example. Which example we choose? Can sin theta greater than 1? So we are going to check with that example. Which is that example? A, B, C. Here 90 degree, 3, 4, 5. So let me mark here it as theta. And now I am going to calculate sin theta. Same example, 3, 4, 5. Then I am going to calculate sin theta. This is angle theta. What is sin theta? Opposite by hypotenuse. 4 by 5. Sin theta opposite by hypotenuse. 4 by 5. What is the speciality of the quantity 4 by 5? Here the numerator is less than the denominator. Here the numerator is smaller than the denominator. So this value is less than 1. So what it says? This example says that sin theta is less than 1. Are you following me? Why? Because from this example we got the value of sin theta as 4 by 5. It's a quantity less than 1. But with this example only, we cannot say that sin theta is greater than 1. This statement is wrong. Because one example we checked where there we got sin theta less than 1. With that example, with that one example only, we cannot say that this is wrong. കാരണം ഇവിടെ sin theta greater than 1 എന്നാണ് വന്നേക്കുന്നത്. പക്ഷേ ഈ എക്സാമ്പിളിൽ നമുക്ക് sin theta less than 1 എന്നാണ് കിട്ടിയത്. അപ്പോൾ നമുക്ക് ഒരു എക്സാമ്പിൾ കൂടെ നോക്കാം. അതിലും കൂടെ ഇങ്ങനെയാണെങ്കിൽ ഈ സ്റ്റേറ്റ്മെൻറ്റ് റോങ് ആണെന്ന് നമുക്ക് പറയാമല്ലോ. So let me consider one more example. So for that purpose, let me draw another triangle like this. And here I am marking the side as some 1, 1. No, let me mark the side as, okay, otherwise it's better to mark the side as 13, then 12. No, let me think about that. 13, 12, then 5. I'm see one example over. ഞാൻ എന്താ ചെയ്യുന്നതെന്ന് നിങ്ങൾക്കൊരു പിടുത്തം കിട്ടിയിട്ടുണ്ടാവുമല്ലോ അല്ലേ? ചില കുട്ടികൾക്ക് ഇത് സംശയം വരും. ഒന്നും കൂടെ റിപ്പീറ്റ് ചെയ്യാം. എന്തായാലും പല കുട്ടികളും ഇത് സ്പീഡ് അടിച്ചിട്ടാണല്ലോ കാണുന്നത്. അപ്പോൾ അവരെ സംബന്ധിച്ച് ഇതൊരു സ്പോയിലാവില്ല സമയം. സി in this textbook the statement is given as sin theta is equal to 4 by 3. So it says that sin 4 by 3 is a quantity greater than 1. So they indirectly says that sin theta is a quantity greater than 1. So I am going to check the validity of that statement. In order to check the validity of that statement, I took a right triangle. Right triangle. You know what is the problem of online education? Let me tell you. നിങ്ങൾ എൻ്റെ മുമ്പിലില്ലാത്തതുകൊണ്ട് നിങ്ങളുടെ മുഖം കാണാത്തതുകൊണ്ട് നിങ്ങൾക്കിത് മനസ്സിലാവുന്നുണ്ടെന്ന് എനിക്ക് അറിയത്തില്ല. അപ്പോൾ എൻ്റെ മനസ്സ് പറയുകയാണെങ്കിൽ നിങ്ങൾക്ക് മനസ്സിലാവുന്നില്ല. അപ്പോൾ ഞാൻ വീണ്ടും എടുക്കും. ഇനി എൻ്റെ മനസ്സ് പറയുകയാണെങ്കിൽ നിങ്ങൾക്ക് മനസ്സിലായെന്നാണ് ഞാൻ മുമ്പോട്ട് ഫോർവേഡ് ചെയ്യും. അപ്പം എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ അറിയാത്തതുകൊണ്ടാണ് ഓക്കെ ഇങ്ങനെ വീണ്ടും എക്സ്പ്ലെയിൻ ചെയ്യുന്നത്. So in order to check the statement of in order to check the validity of this statement, I took an example. Okay, and I am going to check whether sin theta can be greater than 1 or not. So for this example says that sin theta is less than 1. But with this example only, we cannot conclude that this statement is wrong. Okay, actually it says that sin theta is greater than 1, but our sin theta is less than 1, but our statement says that sin theta is greater than 1. So with this example only we cannot say that this is wrong. Let me check one more example. I took this example, okay, because we need at least 2 examples to check the validity. Okay, so so let me നമ്മൾ ആദ്യത്തെ ക്വസ്റ്റ്യനിൽ ഒരു എക്സാമ്പിൾ എടുത്തിട്ടുള്ളൂ. ഒരു എക്സാമ്പിൾ മതി എങ്കിലും നിങ്ങൾക്ക് മനസ്സിലാൻ വേണ്ടിയിട്ടാണ് ഒരു എക്സാമ്പിൾ എടുക്കുന്നത്. ഓക്കെ, ഐ ടുക്ക് വൺ മോർ ട്രയാങ്കിൾ, റൈറ്റ് ട്രയാങ്കിൾ എ ബി സി by the sides is 5, 12, 13. So can this side can I give this 5, 12, 13 for a right triangle? So we are supposed to check that whether these sides are possible or not for better understanding. Clear? Otherwise you may think how Shibin sir got this 5, 12, 13 as the sides. Let me check. There exists a reason. I need to check whether these sides are satisfying the Pythagoras theorem. Hypotenuse square is equal to what? Base square plus height square. That theorem satisfies or not. Okay, so in order to check that, let me calculate hypotenuse square separately. That means LHS I calculated separately. I am going to calculate separately. Then RHS side also I am going to calculate separately. RHS side is base square plus height square. Okay, then here the hypotenuse square is 13 square, that is 169. Then base square plus height square, 5 square plus 12 square. 5 square is 25, 12 square is 144. That is what? 169. So hypotenuse square we got it as 169. Then base square plus height square we got it as 169. So the sides are satisfying Pythagoras theorem. Clear? Is it clear for you? Okay, so we can choose this as the sides of a right triangle. And here I am marking this as theta now. Any problem? If you want you can mark theta here. Okay, I'm going to mark here. So sin theta, I'm going to calculate the value of sin theta. Sin theta, what is that? Opposite by hypotenuse, 12 by 13. What is the speciality of this? Here also yes, tell me. Numerator is greater than the denominator. Sorry, numerator is less than the denominator. If numerator is less than the denominator, the value should be what? Always less than 1. Okay, so what it says, this statement is wrong because we got 2 examples where sin theta is less than 1. So this statement is wrong. So here we can write the wrong because this is the reason. Okay, then I will give you a very good explanation other than this. Okay, those who are having common sense, without example they can conclude. Do you want to see that? See, I'm going to mark it as theta. Okay, I'm going to calculate sin theta. Sin theta is equal to opposite by hypotenuse. Opposite by hypotenuse. Which is greater, this side or hypotenuse? So sin theta is equal to opposite by hypotenuse because we need to check the validity of that sin theta, isn't it? Sin theta, isn't it? So this example, sin theta is equal to opposite by hypotenuse. Which is greater, this side or this side? We know that always hypotenuse is the longer side. So this should be larger than this, or this should be bigger than this, or this should be greater than this. That means denominator is greater than numerator. In other words, numerator is less than the denominator. So the fraction should be always less than 1. No? Why? Because sin theta is opposite by hypotenuse. Here the denominator is hypotenuse. Hypotenuse is always longer than any side. അതായത് ഡിനോമിനേറ്റർ ഈ ഫ്രാക്ഷനിൽ വലുതാണെന്നല്ലേ എൻ്റെ അർത്ഥം. ഇഫ് ദ ഡിനോമിനേറ്റർ ഇസ് ഗ്രേറ്റർ ദാൻ ദ ന്യൂമറേറ്റർ, ദ ഫ്രാക്ഷൻ ഷുഡ് ബി ഓൾവേസ് ലെസ് ദാൻ 1 ലൈക്ക് ദിസ്. ക്ലിയർ? So this is a perfect explanation for that, and this is the 2 examples for that. Okay, and you please note it somewhere in a corner in the notebook because this is very important. Okay, so with this we are going to wind up the discussion of exercise 8.1, and the very next day we will start the very next session in the chapter trigonometry. That is going to be such an interesting session for you. So it's a time to say, yes, tell me. It's a time to say a very good bye. Thank you, and wait for the next video. Bye.